Okay, this is the video for test 3.1. This is going to look at the work covered in lessons 3.1, 3.2, 3.6, and 3.7. So the first part is, this is actually, although it's a warm-up, this is actually part of the test as well. So the first part of the test is identifying functions from lesson 3.1. So for functions, all we're doing is we're just looking at the x values here. And if they're all different like this, then we say that it's a function. If I was to have a repeat value, so if this 5 here was, say, a 2, I could say, oh, look, I got two 2's here. That would not be a function. And there's lots of different ways they can ask this question. So this is all really still part of question one. Normally, you're not going to get a true false type question. You're going to have to identify which are functions, and they'll give you like 5 to 6 to identify from. So for this one, this is where we use our vertical line test. If we only have one dot on the line, then it's a function, but you have to check at every single point. Now, I can see already on this side of the picture here that I have 2 lines on one dot. And for that reason, I know that it's not a function. For this one, what I'm doing is I'm looking at the arrows from the numbers on the left. Remember, we're only interested really in the x values here. So one arrow, one arrow, one arrow, one arrow. I know that this is a function. Now, if you have to write it out, you could. So notice that 1 goes to 4. Notice that 2 goes to 1. And I'm going to run out of room, but 3 goes to 1. I'll write across here. And 4 goes to 2. And remember, we're only looking at the x values here. So 1, 2, 3, 4. So we're good. They did try and trick us by putting 2 arrows going to the y value, but that's not what we're looking at. We're just looking at the x values. So if I was to add, say, an extra arrow in here, then this would not be a function because I have 2 values coming from the 1. 1, 1, and 1, 4. So there would be a repeat x value there. Vertical line test, I can quite easily see this one here. If I draw a line on this side of the picture, you can see that it passes through more than 1 point. And for that reason, this is not a function. We just have to be careful when we're doing questions like this, not to get lazy and perhaps just draw 1 point. This one, it's pretty much not a function everywhere. But if I drew a line here, it would only pass through 1 point. So if you can find anywhere on the picture that's more than 1, the answer is going to be no. Just looking at x values, here we go. So I'm already noticing there's a repeat for this one. So this one is not a function. And then we'd have to select all the ones that were actually true. Now, I wish I'd paid more attention as I was going through. So let's have a look. So 1A, so A is, B is not, C is, D is not, and E was not. So if my memory is correct, A and C were the ones that were correct. And there you go. So it's not a multiple choice question, it's a multiple answer question, and you have to answer for more than one picture. Unfortunately, 4 out of 5 on this is not good. So if I thought E was also a function, I would actually get the question wrong, and there's no partial credit on questions like this. So you got to pay attention as you're going through. Identify an element that could replace the missing value and create a relation that is a function. So we got to replace this. So I just got to make sure I don't repeat an x value. So I can see 1, 2, 3 on here. I don't see a 4 or a 5. And actually, I don't see a 9 either, if I'm just sticking with single digits. So 4 looks good. 5 looks good. And I think I said 9 as well. Obviously, if I type in 1, that's not going to say correct because I already have a 1 here. So remember, just once again, just looking at the x values for this. Relation G is shown below. Select an ordered pair to make the statement true. Relation G represents y as a function of x when which coordinate is removed. So right now, this is not a function because I can see that there's a repeat value here. And as I'm looking at this, I can see this happens when the x value is -1. And actually, I can just look at this straight away. It's the only one that actually has -1 as my x value, so it must be this answer. And you can see that -1, -3 is down here. So if that point was removed, then I would just have 1 point on this line, and that would be good. Obviously, 1, 2 is another possible answer, but as this is multiple choice, and that's not one of the options, I can only pick one of the answers that's given. Drag the black movable point to a point on the graph so that relation becomes a function. Now, in reality, this is a click question. You would click on the square where you think it should go, but we can't do that, so we're going to have to do a drag. So right now, I do need to drag this because right now, this is on a line with one of the points, so that would have a repeat. Same here. Same here. But if I move it to here, then I just have, there's nothing else that's on this line, and that's the only place it can be. It's got to be somewhere on this line here. Doesn't matter how high you put it up the line, but certainly on the line x equals 2, there's only 1 point. Can't put it on this line here because you'd have 2 here. Can't put it on this line here for the same reason, and same reason here. So that's the only possible answer, somewhere along this line right here. And that's actually the first section of the test. So functions, and then evaluating functions. Linear regression and making predictions kind of come together. So we just split those questions up a little bit. So there's going to be basically 4 questions in each of the 3 sections that we're actually going to look at. So let's look at lesson 3.2. So we can try and do these questions by hand, but we run the risk of making a mistake. So what we're trying to do is we're going to let the calculator do the hard work for us. We're going to tell it what the equation is. We're going to say what the x value is. And we know this is the x value because notice over here, x is in parentheses. So if there's a number in parentheses, that must be the x value as well. Now, if we actually just type in the equation, Desmos thinks that we actually want a graph drawing, and you can just about see that graph. So that's not what we want for this question. So to let Desmos know, we just use a capital letter instead. And then if we click Add Slider, now you can try dragging this along, but you don't want to, because for one, you can only go up to 10 for this one. And also because it's so much easier just to delete the number that's there and replace it with a correct number. So this answer says 8. And we're good. This, of course, could be multiple choice, but there's no reason really to have multiple choice. This could easily just be a type-in question. Now, we've got to be careful on a question like this, though, because it's so tempting to just do the same thing. Open up your calculator, type in 5x minus 3, remembering, oh, I need a capital letter, not a lowercase letter. Set the slider, and then set the slider to 17. The answer is 82, but this is the wrong way of doing this question, and it should say wrong as well. So the reason this is wrong is, notice the 17 is not in parentheses, so that's not the x value this time. In fact, the question even says, what is the value of x? So we're trying to figure out, basically, what number can I set this slider to so I get an answer of 17? Now, I guess we could just drag it along until we find the correct answer. And there you go. You can see the answer is 4 for this question. But really, we want to solve this a little more methodically, particularly if it's not a whole number. So what we're trying to do is, as these are both f of x, this one and this one, we just set the 2 equations equal to each other, and then we can solve them by hand. So add 3 to both sides. 17 add 3 is obviously 20. And then you can divide both sides by 5. And 20 divided by 5 is 4. So we still end up with the same answer that we had before. But like I said, you might not always get a whole number, so it might be better to just make sure you're answering the question correctly. So pay attention to which are you finding. If they give you the x, you're finding the y. If they give you the y, you're finding the x. And you just got to make sure you're answering the right question at the right time. Now, that's evaluating functions algebraically. We also did this graphically as well, like the picture from here. So I can see that it's 6. I can see it's in parentheses, which tells me I'm going to go from x equals 6. So x equals 6 would be a vertical line here. Now, if I go downwards, I don't reach the graph at all. So I'm going to go upwards. Once I get to the graph, I'm going to stop. And if we know x, obviously we're trying to find out what the y value is. So we just read across to the y-axis. And you can find the answer like that. They're pretty quick questions, but it's making sure that you find the right thing at the right time. F of 3 for this one. Now, this is a bit of a trick one, and this is why I put this as 7b. So there's 3 on the x-axis. Now, if I move up, I don't get to the graph. In fact, if I move down, I don't get to the graph because I'm already at the graph. So for this one, I can literally just read straight across to the y-axis, and you'd find that it's 0. So they're the ones that people often get confused by, and they prefer the ones that are part A. Now, in reverse, kind of similar to what we saw before, this is not in parentheses, so this is not the x value. So -7 is actually the y value. So we're going to start from -7 on the y-axis, and y equals -7 is a horizontal line. So if I go to the right, I don't reach the graph. So let's go to the left, and then read up to the x-axis. Obviously, that's the value I'm trying to find, and hopefully that should be good. There we go. And there are some other questions here where you can actually try these. You will never get a question as difficult as this, but it's really just to make sure you can remember where all the different things are on the keyboard. So my first thing for noticing for this one is there's a fraction. So you want to click the divide button straight away, and then you can start typing things in. Once again, for the 1/2, same thing. 1 divided by 2, t, and then there's my squared button. And then on the bottom here, this one's actually got an absolute value, which even if you don't remember what it is, you can still actually type this question in. And I forgot because I was so busy focusing on typing it in, I didn't actually type in a capital letter for this one. And actually, you don't have to unless it's really X or Y. So if you notice for this one, it didn't try and draw a graph. So it's okay with us not doing that. And then I can just change this to -10. Hopefully the answer is 4. Hopefully I typed it incorrect. There we go. And we'll try these ones while they're here because they're fairly quick. This is in parentheses, so I know this is the X value. So start from 5, read across to the Y-axis. There you go. So they're literally 5-second questions once you know what you're looking for. F of 2 is right here. Read across, 0. So I'm already on the graph, so I don't need to move up or down. And for that reason, I can just read straight across to the y-axis. There's that kind of the trick question, if they want us to give that. Or in reverse, this time not in parentheses. Oh, we got a decimal here. That's not super helpful, but 5.5, that would be between 5 and 6. Read across, and then read down. I'm going to guess this is supposed to be 7. There we go. And then the last part of the test is based on linear regression. So the steps are here. You're going to go to your calculator. You're going to click on plus. You're going to click on table. You're going to then type in whatever values you have, either from a horizontal, vertical table, or from coordinates, or from a graph. Once you've typed those in, you want to click on, first of all, you really want to click on magnifying glass because you want to check, is this linear? For this test, it will be, but later on in the year, it will not be. And once you found out what type of regression it is, click on add regression. Automatically, the default is linear, which is what we're going to be using on this test. And then you can just look here and write down the answer. If we do need to change it, there is a drop-down menu. But for this test, linear regression is what we're going to be using. So just a quick review of the 4 different methods. The vertical table is probably the easiest one. So you can see the numbers 5, 10, 15, 20, and I got the same numbers here. My y values, and then click on linear regression and it'll give you the answer. So that one's probably the easiest one to type in. For the horizontal one, the top column is going to be the top row is going to be the left-hand column. It does go down to 65 if I scroll down just a little bit more. And then the bottom row is the Y values. So that's kind of important to know as well. So some people like to do it one at a time, like 64 and 62, and enter it across ways. That's up to you. Coordinates, I just do these one at a time. 1, 3, 1, 3, 2, 5, 2, 5, and then so on. Just do it for each of those points. And if you have a picture like this, you just got to work out each coordinate as you're going along. Sometimes the scale's not super helpful, so there's no number here, but it's between 0 and 2. So this must be 1. And then on the y-axis, that would be 0. 2 here, and it's between 0 and 4. So that must be 2. And you do have to make sure you get every value correct, because if you get one incorrect, you could possibly end up with a wrong answer. Okay. All right, so let's have a look at our first question then. So this is the most difficult version of this question where we have to enter the values ourselves. Let me go full screen here so we can see this a little bit better. So my first value certainly looks like 10, 0. So let me type that in. This one looks like 15 and 20. And this one is 20 and 40. And it might be at this point, we actually notice that there's a pattern here. I can see the ones on the left are going up in 5s, and I can see the ones on the right are going up in, going up in 20s. But that last one you can also see is 25 and 60. So remember to click the line, and that also tells you, does this picture look like this picture? So that's a good start. Then we can click on the add regression, and the equation for this one is 4x minus 40. And you can indeed see that that goes there as well. We don't need to explain our thinking for this one. That will be perfectly okay. And we can also, if we need to, if we're not sure how to do this, if I took off the linear regression, you could actually just type in each answer and just check if it looks close. So if I did think it was answer A, for example, I think you can see that that does not go through all the points on the line here. Whereas if I change it to 4x minus 40, I'm hoping that you can see that that is indeed the same line. Okay, so there's a couple of different ways that you can answer those questions, or doing extra little checks. And there's the other answer, just to prove that that is the correct answer. All right, this time, let me go back to My calculator. So this is the horizontal table. So I am personally going to do the top row first, and I'm just going to go down using my arrow key here. 14, 16. Looks like these are going up in twos, so there definitely looks like there's a clear pattern here. Not so much for the ones on the Y column, I don't think. Unless, well, some of them are going up by twos, but it doesn't look like every single one is. 17, 19. I would have thought that would have been 21, but we don't always have perfect straight lines. So click on the thing. So yeah, it kind of looks like it's curving a little bit, but overall, there's definitely a trend of this going upwards, and I can imagine a line going through here. So I think the straight line's appropriate for this one. Now remember, there's also this thing called the correlation coefficient as well. So if this is very close to 1, it means it goes through every single point. Anything above zero point 0.7, we consider strong correlation. So this one's actually 0.99. So yeah, it's very close. And actually, as you look at those values, that then most of them are actually kind of touching the line. That one's just a little bit away, and that one's just a little bit away as well. Now, this time, actually, we have fractions here, so this is not as helpful as it might possibly have been. And we've got to try and figure out which is the closest to this. Now, this 0.54 at the end doesn't actually look like any of these numbers at all. We always really want to focus on what the fraction is. Now, with this being such a horrible one, that's not going to change. That decimal is not going to change into a nice fraction. One thing to notice, though, is notice the slope is positive. So I know straight away it's not these two answers here. So it's either 7/8 or 8/7. So as we have our multiple choice, we can actually just check. 7/8, it says is 0.875. Well, that's very close to that answer then. And just to confirm that it's not the other way around, 8 divided by 7 is 1.14. That slope is definitely not 1.14. And for that reason, I'm pretty confident that it's this answer here. And just to check, though, we should type in those answers. Now, I'm actually this answer here. There we go. That looks much better now. There we go. And also, this does have a positive y-intercept as well, whereas this one actually had a negative y-intercept. But if I do type in the wrong answer by accident, like I nearly did, luckily I was about to check my answer, and I would have been a little concerned by this. This line does not seem very close to those points. Whereas if I type in the correct answer, that looks much closer. It's not perfect, but you can certainly see that it is very, very close. So we're picking the best answer. And for that reason, it would be that slide there. So that's how we find the equation. And I'm going to assume my last two questions are making the predictions from that. That's really the purpose of actually doing this one. So use the line of best fit to determine the output if the input is 50. Now, I picked those words just because they're the ones we don't use very often. Normally, they'll give you say it's the X value, or they'll say it's the Y value. Sometimes I'll say domain for X and range for Y, but they can also say input for X and output for Y. So I just wanted to make sure that that was included within here as well. So first thing we have to do is, just like we did before, we just got to copy the table. This is, of course, the easiest one to type in because it's our vertical table. 3, 7, 12, 15, and 18. Just kind of do a quick little double check to make sure that looks good. Let's click on magnifying glass. Yeah, there definitely seems to be positive correlation here. So let's go ahead and click on the line, and our linear regression, once again, we got 0.99. This is very close to a straight line, so I think we've probably got the right one here. And this time the rule is not really important. We're not actually going to use the rule except to help us figure out what the answer is supposed to be. So this question says, determine the output if the input is 50. So as the input is x, that means that x equals 50 for this question. So I'm going to type in x equals 50. Now, I don't see 50 right now because this only goes up to 20. So let me zoom out a little bit. Help if I can type, of course, as well. There we go. And now you can see that vertical line at x equals 50. And if we click on where it crosses the line of best fit, it'll actually give us the answer. So as we know the x value, we're trying to find a y value. So 49 should be the answer to this question. There we go. Sometimes you have to round that answer as well, etc., etc. All right, this one looks like we've got a bit of a word problem going on here. So I can see I got a table. I can see I'm making a prediction, and I'm going to make a prediction in a short while for when is the height of a tree 38.5 feet. And it mentions that we have some data on trees here. It does say that X is the age of the tree. So after 1 year, it's this height, 2 years, it's this height, and so on. So let me click on my table, and I'm just going to do them one at a time as its coordinates. So 2, 2, 3, and we got some decimals this time as well. So it's a good job that we can use this calculator because this would be kind of difficult without. 5 and 3.7. Now, normally you'd probably get more than 5 values, but just to save time, we've kind of decreased this a little bit just so we don't spend too long typing. I'm going to click on that magnifying glass again just to make this a little bit clearer. And that definitely looks like a straight line pattern. And it looks like the line goes through almost every point. Not quite perfectly, but 0.999 is very, very close to that. So how many years would it take for the tree to reach a height of 38.5 feet? So height in this case is the y value. So this time I'm going to type in y equals 38.5. Now, once again, I don't see it right now because it only goes up to 5. So let me zoom out. There we go. And look where it crosses. And I got an answer of 67.10. Now, it does say on here, round your answer to the nearest feet. And remember, if you're not too good with rounding or you forget the rules, you can actually just type round in. Let me just make sure I get a few more numbers in here. 10714. 10714. And Desmos will actually round the answer for you. And just because I thought it was hilarious as I made up the question, I made sure the answer was 6767. And then hopefully that will be the answer to this question. Nope, doesn't look like it even says anything. Oh, this one didn't actually. Oh, check your answer up here. There we go. So it was 67. Just as a reminder, if you want to round to a different degree of accuracy, you can put comma 1 if you'd like it to one decimal place, 2 for two decimal places, and so on. So tenths is one decimal place, hundredths is two decimal places, and thousandths is three decimal places if you want to use that. And that should be the last question. So yeah, there's 12 questions on the test that you're going to take today. The group, like I said, 4 on functions, 4 on evaluating functions, 2 graphical, 2 algebraically, and then there's 2 questions on linear regression and 2 on making predictions. But essentially, this is the same topic, really.